So today we will see differentiation of logarithmic functions. Before that, we should know about the basic properties of logarithms, and that will be used frequently while doing the differentiation of the functions when we are taking the log on both sides. So first property, some property you must know that you must be knowing before also that log of the product of two functions with the base a, any base m into n, m into n means product. Log of the product of the two functions will be equal to the log of some of their separate log. Log m to the base a plus log n to the base a. A can be any base. Where always log is for positive numbers. Log cannot, we cannot find the log of a negative number. So here all should be positive, means m should be greater than 0, n should be greater than 0, because positive numbers we can find the log of positive numbers, and base also should be greater than 0 and it should not equal to 1. Base should not equal to 1. We cannot take one base. So generally we have two types of log base 10 natural log and log base e. So what is log actually? The log is if, for example, 10 raised to power 2 is equal to 100, correct? This is called exponential form. When it is written in the form of power, it is called exponential form. Exponential form. Okay. So then when we are converting it into the log, this, if you see the left side, this is the power. This is what exponent or power, same thing. This is the exponent, and this is called exponent. That is also called as power, you can say. And this is the base. Okay. So when you convert it into log, this exponent, you will write log base 10. This will become 10. This base will become 10, and only this 100 will come this side and 2 will go that side. So log 100 to the base 10 is equal to 2. So this shows that if the base is 10, so log 100 will be log 2, log 1000 will be log 3. So this is the basic definition. If you can write in general, if a to the power, if a to the power x is equal to b, then the definition of the log is, then we can say that log b to the base a is equal to x. These two will be interchanged. This will come here and this will go there. These two will be interchanged and this will become the base. This is also a base left side, but it is the base for exponential power exponent. Here, this is the base of 10. So it is read as log b to the base a is equal to x. That is the definition of log. So we are not going into the deep study of the log, otherwise it has a very vast application. But we are using the log in differentiation, so we must know about some formulas of log. So this is the product. If the two numbers, it can be applied for three numbers. If m and p, then all will become plus. Okay. So this shows that log cannot go directly. It will convert into plus. Got it? When the numbers are in with any base, this is, if it is in division m upon n, then it will become log m to the base a minus log n to the base a. Whenever we are dealing with some numbers, the base is generally 10. When we are dealing with the x, y, z, the base is exponential e. And if third most frequently used property is m to the power n, m to the power n. So then this n will come in multiplication n log n log m, n log m to the base e. Okay. So product we have seen multiplication, division. There is no formula for, just remember, there is no formula for log m plus n or minus n. There is no formula. Okay, you have to just add and subtract and then find the log. And no formula for addition and subtraction. Only for multiplication, division, and power to the power. Okay. And one more thing you must know, because it will come in differential equations. Log if if log e to the base e, if the base and this is same, then it will be equal to 1. Okay. Log e to the base e is equal to 1. Correct? 4. So whatever values, if it is a and base is also a, then it is also equal to 1. Log 10 to the base 10 will be equal to 1, because 10 is power 1 is 10. Similarly, if on exponential power log to the base e, x means we have the base e, same base, then this log and exponential will be cancelled and we get only x. This will be used in differential equations. In differential equations, we will use formula, we will use in differential equations. Okay. And log, if you have given log m, so most probably we will use this formula, and this formula, and this will be used in differential equations. So here frequently used formulas are this one, these three you must know. And log m to the base n, if need anywhere, we can write it as log. If you take it in the denominator, means reciprocal, then the base will become n and this will become n. This will be changing, interchange. Okay. And as I told you, log 10 to the base 10, log e to the base a, or we can write log 10 to the base 10 is always equal to 1. So same base, same value will give you the value of log as 1. So these are the some basic properties of log. Then we have now differentiation of logarithmic function. Correct? So whenever, what are the conditions when we have to use the log to differentiate? Why we can't differentiate directly, and when we will understand that we have to use the log before differentiation. Before that, you must know the two formulas that we have already studied: d by dx of e to the power x exponential is e to the power x, and d by dx of log x is 1 by x. Here the base is e, exponential. Base is exponential. Huh? When we are using x, y, z, the base is obviously exponential base. If it is some other number, then we have to write. Otherwise, no need to write. When we are doing by log, means first we have to take the log and then differentiate. Taking log and then differentiating. If a function is given as function to the power function, if you have given a question which is function to the power some function, in this case you have to take log first, both sides, and then differentiate. So I'll take one question. For example, we take one example. Differentiate e to the power x cube. E to the power x cube. See, somewhere we can differentiate by both the ways. Previous chain rule also be applied somewhere, but when the function to the power function, it becomes very easy. Some complicated questions will become very easy when you take the log. So differentiate e to the power x cube with respect to x. This is our question. Huh? So what we will do whenever we will see, okay, function to the power function. So let y is equal to e to the power x cube. Then before differentiating, taking log on both sides. Why we are taking log? It will make it easy. Taking log on both sides, right side, left side, we can take anything. So on both sides, same operations can be applied on both the sides. So we are applying log on both sides. So left side, we will get log y, and right side, you will have log e to the power x cube. Now see which formula. Now you have to apply right side first. Formula of log should be applied, that we have seen these formulas. These formulas will be applied to make it in the simplest form. So here log m to the power n. M to the power n formula will be applied. So I'm again writing log m to the power n is equal to n log m. N log m. So n is x cube. So x cube will come here, and this will become log e only. And base is already, as I told you, that if it is not written, it is e with the function. So log e to the base e is 1, as I told log. So this is 1. So here we got log y is equal to x cube. Now differentiate both sides with respect to x. Now differentiate both sides both sides with respect to x. Okay, means dy by dx. So d by dx of log y, d by dx of log y left side, and right side d by dx of x cube, d by dx of x cube. Okay, right side there is no problem, x cube we can differentiate nx n minus 1. How will you differentiate log y? As I told you that if you are differentiating with other variable log y, either you use direct formula, or you can multiply divide by dy, and dy will come here, dx will go there, then dy of log y, dy dy of log y into dy by dx, into dy by dx, then log y. Now we can differentiate log y. So the answer will be 1 by y dy by dx. Or as per the direct chain rule, differential of log y is 1 by y, then dy by dx. Side is y, so y is dy by dx will come here, is equal to here nx n minus 1 3x square. Differential of x cube is what? 3x square, and this y will be multiplied here. So after this, always at last you get dy by dx is equal to y into 3x square. But this is not the answer. Y, again you have to put the value of y from this, substituting this value y from here, substituting this value, we get the final answer. Therefore dy by dx is equal to, you can write first 3x square into e to the power x cube. This is the answer. But directly also you can do this question, but somewhere you will find very difficult question there. If you go directly, it will be a problem. Okay. For example, I will take one question there. Yes. If next extra question, then we will start exercise. Our question is, if y is equals to log square root of 1 plus sine square x divided by 1 minus sine x. 1 minus sine x. Okay. Then find dy by dx. Then find dy by dx. Okay. So here again you can see that log is already given right hand side. So there is no need to take log again. We can use it log. So I think I will change this question. I am changing this question. Okay. So this log is not there. Suppose we have not given the log. We have to find the differential of this one. Okay. So what we will do, we will take similarly we will take log because this is the power of something. When it is the power of something or 2 powers, 3 powers, we should use the log. Okay. Because here it is the power is the number. If you have the power, suppose if you have given log cos x to the power x, okay, you cannot use the any direct chain from the chain rule. You cannot use the formula because there is no formula for x to the power x function to the you have the formula x to the power n, differential of x to the power n and a to the power x, but you don't have any in the formula where function to the power function is there. No? So that's why in that case we cannot go by any other way. We have to do by using log. Okay, so I will take that question. After that we will come to this question. So okay, suppose if you have a cos x to the power x, here you have to take log both sides, otherwise you cannot differentiate. So function to the power function cannot be differentiated directly. There is no formula. Okay, so what we will do, we will taking log on both sides same way. The process is same that we have done in the previous question, taking log on both sides, taking log on both sides. So we get log y left side, log right side, log. Okay, taking log on both sides, cos x to the power x, cos x to the power x. Now just you can apply the log formula for right hand side. So left hand side log y is equal to log m to the power n x log cos x. You can see now it is converted into very easiest form to differentiate it. Now differentiate with respect to x both sides. Now differentiate both sides with respect to x. Okay, x why we this is the function of x. We have to differentiate with respect to x only. So d by dx, if it is given in y, we have to differentiate with respect to y. Then in that case dy dy will dx by dy will come. Okay, that is the different thing. So now d by dx of log y, left side, right side, d by dx of x into log of cos x. Now you can differentiate directly log of x into log of cos x. How will you differentiate x into log of cos x? Hmm. Which formula will be applied here? First function, second function. First function you have to leave, then differentiate second function. I'll write here because of the shortage of the space. Here I'll write first function as it is. Okay. Then differential of second function product formula. D by dx, just writing it, then we will differentiate. D by dx of cos x plus leaving the second function log of cos x and differentiate the first function d by dx of d by dx of first function x. Okay. Now differentiate. As I told you, left side always log y. The differential of log y is 1 by y and dy by dx. Differential of y is dy by dx. First differential outermost, then inner. Similarly here now x. What is the differential of this log cos x? So as we go from the outer one, so what is the differential of log x? 1 by x, so 1 by cos x. Then inside this cos x, differential of cos x is minus sin x, right in the bracket. Okay. Then plus log of cos x as it is, and differential of x with respect to x is what? 1, only 1. Dx you can take cancel, or you can take 1 power 1 minus 1 x cos 0. Anyway, you can just then the d by dx of x is always 1. That's it. Now this y will come here, so we get dy by dx is equal to y into minus x sin x upon cos x. We can write 10x and plus log cos x. At last, don't forget to put the value of y. This y is replaced by this number at last. So we get at last the final answer is dy by dx of cos x to the power x into minus x 10x plus log cos x plus log cos. So like this, if it is a function to the power function, then we have to take log and then we can differentiate. So next exercise, our next exercise is based on these types of differentiation. If you see the number 4, 4, 6, 7, 8, 9, 10, and 11, they are same type. The difference is they have the functions, two functions in addition or subtraction. Plus is there, you can see here, plus or minus is there. So that's why. So first we will do the simple type where we have product of powers that can be simplified by using logarithmic, by using log both sides. So we are taking the question number 1. Okay. So this question, one more thing, if you have three functions in product, if three functions are in product, then you can differentiate any function first, then leave second, third, plus second, leave first, third, plus third, leave first and second. Okay. But here we are using by log. So same way we will go, let y is equal to cos x. So you should actually analyze the question that if it is easily solvable by taking the log, you should go by log. So this is three functions in product. We can directly use also product formula, but that will be, I think, very long. So we have to take log on both sides. Taking log on both sides. Okay. So this will become log y is equal to log of the product of three functions, that is cos x into cos 2x into cos 3x. So this is the formula for product, as I told you, log m into n into p, log m into n into p will be equal to log m plus log n plus log p, log n plus log p. So this formula will be used here. So we will get log y is equal to right hand side the log M and P formula is applied. So we get log of cos x plus log of cos 2x plus log of cos 3x. Okay. Now differentiate. Once it is simplified by using logarithmic formulas, you have to differentiate. So now differentiate with respect to x. Differentiate with respect to x both sides. So we get d by dx of log y. Left side is log y. So d by dx of log y. Here d by dx. Actually, we should write in the starting d by dx. Here d by dx first, and then d by dx will go inside because of plus and minus, as I told you before. So if you put d by dx both sides, this d by dx, okay, the right hand side d by dx will go inside. So you can write d by dx of log. So one step you should also write the starting log d by dx both sides, and then this d by dx will go inside according to the plus minus formula. So in plus d by dx directly goes inside. So d by dx of log cos 2x plus d by dx of log cos 3x. Oh, sorry, cos log cos 3x. Log first function, then cos, then 3x. There are three functions here. One log, second cos, third 3x, and here 2x. Here it is cos 2x, cos or log cos 2x. Here x. So here x we are not considering any other. 2x is the function. Huh? X is a function, but difference of x is 1. That's why directly cos x is a function. Cos is a function. 2x is another function. So three functions. So here 1 upon y is log. What is the differential of log is 1 upon y. Then what is the differential of y is dy by dx. Okay. Here differential of log is 1 by x, that is 1 by cos x. Then go inside. Cos. What is the differential of cos is minus sine. Cos x is minus sine x. Finish here. But here you have first differential of log. Log is 1 by x. So that is 1 by cos 2x. Okay, remember. Then differential of cos. Cos is minus sine 2x. Then again differential of 2x. This 2x is another function. Differential of 2x is 2. Don't forget this 2x. Hmm. Similarly here you have differential of log 1 by cos 3x. Then you will write the differential of cos, that is minus sine 3x. Then go inside, differential of 3x is 3. Okay, that is the final result now. And why we can bring this side, we can write the simplest form. So therefore we can write now dy by dx is equal to dy by dx is equal to this y will come on right hand side, and inside the bracket this is minus sin x upon cos x. So we can write minus 10x minus 10x, then minus 2, 2 is there, sin 2x upon cos 2x, tan 2x, then again minus this 3 we can write the starting sin upon cos will become tan